Hello guys and welcome to TechWolf. In this video we are going to start a full course of Cisco Packet Tracer. In future videos we will be creating different network scenarios using Packet Tracer, we will install Packet Tracer, we will go over UI or user interface of Packet Tracer, but in this video I am going to give you an in-depth understanding what Cisco Packet Tracer is, as it is also useful to know to in-depth understand what Cisco Packet Tracer is before we dive into the course. So, Cisco Packet Tracer is a powerful network simulation tool created by Cisco Systems, and it is primarily used for network design, configuration, troubleshooting and simulation in virtual environments. This tool is particularly beneficial in studying computer networking and preparing for Cisco certifications such as the CCNA or Cisco Certified Network Associate and CCNP, Cisco Certified Network Professional. Let's dive in how Packet Tracer works, its benefits in studying and real-life applications. So what is a Packet Tracer? A Packet Tracer provides a virtual environment where users can simulate complex network configurations without the need for actual hardware. So in general, by using Cisco Packet Tracer you can create real-world scenarios without devices. It includes features for configuring routers, switches, wireless networks and other network devices, allowing users to see how data packets move through a network, for example TCP/IP or UDP connections, interact with devices and troubleshoot network issues. And here are the key features of Cisco Packet Tracer. Simulation mode. Simulation mode allows users to see packet by packet flow through the network. Next one is real-time mode. And real-time mode enables immediate feedback on the functionality of the network as configured. Then we have multi-user collaboration. Packet Tracer users can work on the same network setup in real time, and this is ideal for collaboration, study and team-based projects. Next feature is wide range of devices. It allows simulate routers, switches, PCs, IoTs or Internet of Things devices and more. Command line interface or CLI in Packet Tracer offers practice with Cisco command line syntax, which is essential for real-world configuration. And here is the example of Tracer in studying. For example, a scenario: a student learning for the CCNA certification can set up a virtual network using Packet Tracer to simulate connecting two local area networks or LANs through routers and switches. And here is a step-by-step look at how this might work. In step 1, network setup, the student places two PCs, a switch and a router on each LAN or local area network and connects them through Ethernet cables. IP address configuration, the student assigns IP addresses to each device in two networks and sets up a subnet mask and default gateway to enable inter-network communication. And step 3 is router configuration, where using the CLI or command line interface, the student configures each router with the necessary IP addresses and routers to enable packet forwarding between the two LANs. And in step 4, testing connectivity, using Packet Tracer simulation mode, the student sends a ping from a PC in the first LAN to a PC in a second LAN. And Packet Tracer shows each stage of the packet journey, highlighting issues if the configuration is incorrect. And finally, troubleshooting. If there is an issue, the student can trace where the packet fails and adjust the configuration as needed, learning from the real-time troubleshooting. This hands-on experience is invaluable in mastering network design, configuration and troubleshooting techniques without using physical network hardware. And not to mention that Packet Tracer is absolutely free. And here I will also give you an example of Packet Tracer in real-life scenario. Well, Packet Tracer is primarily used for educational purposes. It has a few applications in real-life network design and management. And first would be network design and planning, where network engineers can use Packet Tracer to prototype network setups before implementing them in a live environment. This is useful for creating blueprint for network expansions, testing new configurations, or experimenting with different network topologies without risking downtime or errors in the live system. For example, a small business planning to upgrade its network can simulate the new setup in Packet Tracer. The engineers would would verify device compatibility, test firewall settings, and simulate traffic loads, ensuring the design works as expected. And next scenario and real-life example would be testing configurations and updates. IT teams in real-life scenarios often need to roll out a new configurations or updates to network devices, and using Packet Tracers they can simulate these configurations first to observe any potential issues. For example, an organization wants to implement a new VLAN or virtual local area network configuration across multiple switches. The network team can simulate this configuration in Packet Tracer, testing for connectivity between departments, access controls and security measures to ensure no disruptions occur. And third one is training and skill development. Even professional network engineers use Packet Tracer to keep their skills sharp and familiarize themselves with new Cisco commands or devices. And this is particularly useful in companies with internal certification programs or ongoing training. For example, an IT team in a company can use Packet Tracer to practice setting up VPN tunnels between remote offices. They can explore multiple VPN protocols and test for latency, encryption settings and failover options. And next scenario would be in troubleshooting incident response simulation. Also, Packet Tracer is limited in its simulation accuracy compared to actual network monitoring tools. It can be used to simulate network troubleshooting techniques. This helps engineers prepare for potential incidents by going through mock scenarios. For example, an engineer may simulate network outage by disconnecting certain routers in the Packet Tracer model. They then use troubleshooting commands like ping or tracer, show IP route to diagnose and solve the problem, training them for similar real-world incidents. And here are advantages of using Packet Tracer in real life. Cost efficiency. Saves cost of physical equipment for training and testing, as Packet Tracer is absolutely free. Flexibility. Enables safe experimentation, which can't always be done on live networks. Learning and development. Provides engineers and IT staff a low-risk environment to test skills. Preparation for live changes. Packet Tracer helps foresee possible issues before applying configurations in production. And here are the limitations. Despite its strengths, Packet Tracer has limitations when compared to actual network simulators or production environments. For example, limited realism. Packet Tracer may not accurately represent real-life device behavior, particularly under high traffic conditions. Another limitation of Packet Tracer is protocol support. While it includes major protocols, it lacks some advanced features found in other network simulation softwares like GNS3 or physical devices. And scalability is another limitation of Packet Tracer. For highly complex networks, Packet Tracer's resources may be too limited, making it better suited for small to medium-sized simulations. And in conclusion, Cisco Packet Tracer is a versatile, accessible tool, especially valuable in educational and training environments. While it is not typically deployed directly in production environments, it plays a critical role in network planning, training and preparation for real-life applications by providing a safe, cost-effective environment to test configurations and gain practical skills. Packet Tracer bridges the gap between theoretical learning and real-world network management.